So off we go. 1-7 builds on yesterday when we talked about exponential notation. Today what we're going to do is multiply things. We are going to divide things, and then eventually we'll get through to a position where powers are going to more powers. So let's do a quick recap first. What are these numbers up here? What are those called? Those are called exponents or powers. That's called the base. So if you go to multiply with the same bases, does anybody either have a memory with a sentence of what to do, how to do it, or anybody want to just tell me the answer to this first one, memories of stuff?
Wouldn't you just add the exponents?
Yeah, we add the exponents, so this would be x to the fifth. Because what this means, x squared means xx. X cubed means xxx. So if we put that all together, multiplying, we'd end up with x to the fifth. So half of the answer would be to add the powers. So adding the powers is about half the strategy we need to get us through that column. Question about the idea of adding the powers, or that first one. So next one, add the powers.
B to the negative third?
It would be b to the negative third. Depending on what the instructions say, you might or might not be okay with that. If the directions for some reason said you're not allowed to have negative powers, we would need to fix that based on yesterday's lesson and homework that you did, hopefully did. How could we rewrite b to the negative third to not have a negative exponent anymore?
Wouldn't we just write it as a fraction?
We can make a fraction, yeah. Who's going where?
It would be like 1 on top.
1 is on top, yes.
Positive b and then positive.
Yeah, a b to the positive 3 on the bottom. Negative powers become positive powers by flipping where they are in the fraction. Sometimes I get people on this one. Thought on this one.
5 with the power of 7.
It is 5 with the power of 7. You don't change the bases ever. Okay, so here we didn't mess with the x's, we just left the x, added the powers. Here, we didn't change the b's, we just left b alone, we added the powers. Here, you don't want to make this 25, you want to leave the 5 alone, add the powers. We're going to add the powers. This one, it is 10. Cubed, agreed.
Negative 1.
Negative 1, that's correct. A little bit of help from our friends and we're good. This has two things that merit a discussion. Anybody spot one thing on this that's worth having a little discussion that we might have confused some people with what happened on this one? Because there's two things that happened here for the first time. It was unlike the other questions.
The x is invisible. Exponent.
Okay, anytime we have a base without a power, it has an invisible 1. So this x has an invisible 1. This x had a visible 2. We add up those powers, that's how we got the 3. That is one of the two things that I had in mind that's worth the discussion, is we continue to add the powers. Anything that has a base, we add the powers. But then there's something else that happened on this one for the first time that was different than everything else.
Is it the 5 and 2?
Yeah, the 5 and 2, for the first time we actually multiplied by like having to multiply stuff. So we need to drop another vocabulary word out there. What are these numbers out in the front called? No, they're not bases because they don't really have powers. Coefficients. So if you have coefficients, we want to multiply the coefficients. And these were the first problems with coefficients. We can't do anything with these as bases. 1, because they're different. And 2, they don't really have powers, although they have 1s. But you're not trying to do anything fancy with 2 and 5 other than just multiply them. Okay, so coefficients are going to get multiplied, powers are going to get added, and you don't change any of the bases. Question about multiply town? So if we cross the line into divide town, how's divide town going to be different? Either from memory or from just reasoning it out. We're going to subtract the exponents because multiplying and dividing are opposites, so we're going to do the opposite thing. Multiply made us add, divide is going to make us subtract. So for this part of the world, half of the answer is going to be to subtract the powers. So this first answer, we come out with x to the second power. If you want to understand why, this has like a quadruple x, this has a double x, and in fraction town you can cancel. 1 with 1, 2 with 2, we see who's left standing, the top had more x's, the top wins. This has x to a positive second power because the top had 2 more powers than the bottom. If we go to do this one,
That's the negative 2.
one possible right answer is x to the negative 2. If the book doesn't really give you very specific instructions of what you're supposed to do with it, I'm completely fine with x to the negative 2. If the book gives you clear instructions not to do negative powers, then this would need rework. How could this get reworked if you're not allowed to have negative powers?
1 over x.
It'd be 1 over x to the positive 2. Chances are they're just going to let you do whatever, because that was the whole point of what we did yesterday. Some of the point of what we did yesterday is just to make today easier. You like negative powers? Then do negative powers. You like fractions? Do fractions. Because you can think about canceling again. X squared would get completely canceled by x to the 4th. You'd have 2 x's left on the bottom. So if you're thinking about this as a canceling question, maybe you like this answer. If you're thinking of subtracting, maybe you like that answer. They're the same to me. I don't care. Whatever would work for me. On a test, I'm just as good with either answer. Homework, you have to obey what the book says. Questions about that one? You ready to go next one? Okay, go ahead. I agree. Again, we have here an invisible 1. So when we subtract the y's, it's positive 2. When we subtract the x's, it's negative 2. When you divide those numbers, we got a 2 out of that, and I'm good with that. And I'm not even going to fix it. I mean, if we had to, we could. The negative power could just go to the bottom, but I think we've done that enough. Then the next one's a little weird, because the coefficients are less cooperative. Anybody have a thought on what we need to do about that?
You have to find something other.
Yeah. Who would that be? 2. 2 can go into both of those. So what are we going to come out with as an answer? 5 over 7. So I might say here is my beginning part. Reduce the coefficients. Like 8 over 4, we reduced by flat out dividing it evenly. But 10/14 is reducible with 5/7. Reduce the coefficients like a fraction. And then we're going to look to subtract the powers. So 10/14 there is handled to 5/7. One way we could write this is now putting the x and the y not as part of the fraction anymore, but just kind of like on their own. Like here, the x and the y's, they just went on their own. They weren't really a part of the 2. The fraction didn't need to be there anymore. My preference personally would be to go make the fraction and then step away from the fraction. Subtracting with tons of negatives sometimes gets people, but subtracting the x powers, what do you think? Not negative 5. It is just an x. There would be an invisible 1. We're doing here negative 2 is subtracting negative 3. And the subtracting scenario here is that 2 minuses makes us add. The adding is enough to get us back to the positive half of the number line. So it is x to the positive 1. For y's, we've got 4 subtracting negative 8. Where does that take you? 12 is correct, up to a positive 12. Because again, the minuses we plus and we got. Question about that? I'm never going to make you do this, and neither will the book, I don't think. But if somebody insisted that you write all of this stuff within a single fraction, where would those things go? Top. These are, remember, invisibly on top of 1s. So those would go tops. Either of these answers is fine with me. I'd put this one. If you like that one, that's fine. Question about that? Here's a what if before I cross another line. If, say, this turned out, I'll change the problem around. If that was negative 4, and that's positive 8. how would my y's be subtracting -4 minus +8?
Negative 12.
-12. Which would make this be -12, and that would be okay. But there would be another answer that would also be okay. How could I change this answer to make another still okay answer? Why?
5/7.
5/7 still. X still at the top. Y on the bottom, but now to the +12. Any of those three would be fine. Personally, I would not care. Depending on the directions the book gives you, maybe these wouldn't be okay, because maybe the book will say positive powers only. I don't know. I didn't write the book, so that's unpredictable. Question about the divide group? So sliding over another column. If powers go to other powers, memory of what happens to that. Multiply powers is going to be sum of my answer. So if we have 3 squared and then cubed on top of that, that means there's a pair of 3's, another pair of 3's, and then a third pair of 3's. So altogether, that's 3 to the 6. You don't need to write that all out ever. I'm just showing you where this came from and why it's true. The shortcut is just multiply the powers and we're golden. So this one, multiply powers. X is now 6. Y is now 12. And on we can go. Question about that. It's a fly, not a bee on the loose.
You're a scaredy cats.
Yeah. If it were a bee, I'd stalk it and kill it, because bees can sting people and they're easy to kill. Flies, I don't try to stalk. Flies are almost impossible to kill. They're so quick.
But I'm
They
glad
also
like,
can't hurt you. They're just going to annoy you.
like they do from Karate Kid.
Catch
But I'm glad I
the
got that.
chopsticks.
It was taunting me last period. It landed on me like twice. And I was just like,
Now you kind of gotta get it done.
they're so quick. Flies are so quick.
Andy Sleater, when I was in like 3rd grade, taught me how to catch flies by the back with their
That's
wings.
amazing. Well, you got one to go get if you want to.
True.
For this one, a thought.
2x negative 10.
There is an x negative 10. I'm on board with that.
Y 25.
There is a y to the 25th. I'm on board with that. I'm not on board with it
So
too.
it'd be a 2 change it to 32.
It does. The 2 changes to 32 because we have to take the coefficient to the power. If we get a coefficient sneaking in there, move my comma, take the coefficient to the power. So we need to do 2 to the 5th. So 2 times 2 is 4 times 2 again,
8
times 2 again,
16
times 2 again. That's where that came from. If you want to bust out a calculator for powers, feel free. If you have a button that looks like this, that's your button. If you don't, look for a button that looks like that. That's maybe your button. But you can find your power button. If you do 2, a button, and 5, and you get 32, that's the button that you do for powers on your machinery. Let's do the variables first on this one. This is going to go x to the
-6.
-6. We're going to go y to the -12. What are we going to have happen to the 3 if we take that coefficient to a power? 3 to the -3 is close to 27.
Negative 27.
It's not -27. Common misunderstanding is to think negative powers make things negative when that's a lie. What do negative powers do from your quiz life? They flip things. Negative powers flip things. So 3 to the 3rd, I agree, is 27. 3 times 3 is 9, times 3 again is 27. 27's in the range, but negative powers flip things. 1 over 27. We don't have to do anything with flipping these because we kind of already did. These were positive powers, they're now negative powers, so in a sense, they've been flipped. That took care of itself. But the coefficient, you have to like manually flip it the old-fashioned way. For this one, let's do variables first again. X would be 4, Y would be 6. How about where 2 used to sit? Now 4, agreed. 3 is 9. Question about that. Sometimes I slide back on a what if to this one, but while I'm here and we're recording in range, I'll throw you with a what if. So if I go negative,
Can you just flip it?
one thing you could do, if we had already completely done the problem, is just take the entire answer and flip it. So we could go with this as an answer. That would be fine. So when I added the negative, that went out the window. We could just flip that answer completely and get settled on this. Another way we could do it is just multiply the powers, so the top has x to the negative 4. The y, just multiply the powers, and y would be negative 6. When we do 2 to the negative 2, it does make 4, but it has to be put on the bottom. The 3 that was on the bottom, when we square it, becomes 9, but it's got to be on the top. These two answers are the same. I wouldn't care personally what you gave me, okay? But if I introduce a negative, you've got to like flip something. So you could either completely do the problem without the negative and flip everybody, or you could just leave the negatives on some of the multiplication power things and just flip the coefficients. I don't care about that. And then here's the king of the day, the biggest of them all. So this has a little bit of everything. There's some multiplying, there's some dividing, there's some powers. So you've got choices. I would recommend you don't do the power first, because when you do powers, everything gets bigger. What's the one operation we did that tends to make things smaller? Divide. So if you have multiple choice options of things that you could do, multiply makes it bigger, exponents make it bigger, dividing makes it smaller. If you ever have a choice problem, do the divide. So here, I'd leave the parentheses, I'd leave the 4, I would just look to do the divide. So coefficients make 2, x's make 2, y's make negative 2, that would all be fine as a first start. Could you have gone 16 times 16 times 16 times 16? You could have, it's not wrong, you'd get the correct path, but that'd be rough to do 16 to the 4th power. It'd be like, I think 65, 536. Somebody do that. 16 to the 4th.
Calculator.
65, 536? Go wait. Thank you. If we go to finish this one, the 2 part would turn into 16. X would create
8.
8. Y would create negative 8. Question about that. I'll hit you with one more what if, and then we'll go look at the old homework. Okay, so here's my what if. If I go negative, I would still divide first and be looking at this. And then you could do this one of 2 ways. Since we already have a finished answer, we could work from the finished answer. Let's act like we don't have a finished answer. If we had an unfinished answer, I'd go x to the negative 8. I'd go y to the positive 8. What would I do about this 2 to the negative 4? 1 over 16. Negative power flips it. 2 to the 4th, 2 times 2 times 2 times 2 is a 16. I'd go 1 over 16. If I had wanted to work from this answer, we could have just flipped everything. Flip the 16, flip this into negative, flip that into positive, changing the sign of the powers, just looking at, that would be another way we could do that. Question, anything about this? So let's take a vote. If we are to do a vocab quiz tomorrow, it will be today's instant replay of the same words, and then we'd add on those 3 notes. The questions would be, how do you multiply with like bases? You'd multiply the coefficients, add the power. I'd say, how do you divide with like bases? You reduce the coefficients, subtract the powers. How do you do powers to powers? You take the coefficient to a power, you multiply the powers. That's our 3 newbies. It would just throw on top of what was yesterday. The new homework will be page 39. Syllabus will know what it is. From a quick look, without my syllabus handy, I'm thinking it's to 48 plus making people try 58. 58, I remember, is a really big looking question with a very small looking answer. So at 58, you get a pretty small answer to a large question. You did something good, but I think it's the 48 plus 58. It's pretty well cued to be what we were doing today, I think. 33 is the page that's due today, so let's rattle through some answers to this. Oh, let's do, you want to do a come around, or you want to do pick one person and they just go and they miss?
Pick one person.
Pick one person, that's fine. So who's going first? Somebody jump in on one, go till you have a mistake. Go ahead.
4 to 6.
4 to the 6th is true.
6 to 3.
True.
4 to 6.
True.
X to 4.
True.
3 to 4.
Maybe, do you have some more punctuation there?
I have parentheses 3.
Yeah, parentheses around 3A, and then the 4 is outside the parentheses. I am with that.
Parentheses 5x to the 5th.
True.
Parentheses negative 4x to the 3rd.
True.
Parentheses negative 3y to the 5th.
True.
Parentheses 5 squared x cubed y to the 4th.
That's fine. You don't need parentheses since it's just a single number. They don't hurt anything to be there, but they're not necessary, so other people hearing that didn't have to have those. Keep going.
Negative 125.
It is negative 125 would be a possible. Another thing I could take is negative 5 times negative 5 times negative 5. I would take that too, but negative 125 also is fine. 11.
81 and 4y's.
81 and then 4y's is fine. You could also have maybe like 3 times 3 times 3 times 3 instead of the 81. I would take that because that obeys the directions. It didn't say you had to multiply out, so my book did multiply out. I'd probably rather have that, but you could argue against it.
Negative 125 for 3b's.
That's true.
And 125 for 3b's.
Okay, that's the first one you went off, but that's it's a nice run. How is 13 has a different answer than 12? Anybody 13 a different answer than what you had on 12?
Negative 5.
Yeah, it's negative 5 with the BBB. The 3 only goes with the B that time. 12 had the parentheses, so a lot of things got repeated. 13 didn't have parentheses, so the negative 5 just sits, and then BBB. 14.
5x.
5x works. 15.
1.
I'd put 1. Anything to a 0 power is 1. Let's pause there. Anybody, those first couple of groups, anything you need me to repeat or clean up? Okay, 16, keep rolling.
1 over 6 cubed.
It is 1 over 6 cubed. My book did not do out 6 cubed. If you did do out 6 cubed, that's okay. You could have 216 down there, but 1 on top of 6 cubed is what I'd be doing. Keep going.
1 over 8 to the 4th.
That's true.
1 over 9 to the 5th.
True.
1 over 16 squared.
True.
1 over 11 to the 1st.
True. And you could just write 1 over 11. We don't need to write the 1, but we can. That could go either way and both be fine.
1 over negative 4 with parentheses cubed.
Yeah, we need negative 4 in parentheses cubed on the bottom, 1 on top. That's a win.
1 over 6x parentheses cubed.
True. Parentheses again.
1 over negative 5y parentheses 2.
That's true. We're in a run of like 4 or 5 in a row that'll all need parentheses.
1 over 3m parentheses to the 4th.
That's true.
1 over negative 3m parentheses to the 3rd.
That's true. And I'm going to interrupt for a second. On 23, if you wanted to, you could ditch the negative completely. You don't have to. My book didn't, but you could. Why on 23 could you ditch the negative completely? Yeah, why is it going to make a plus? It's an even power. So on 23, if you saw the even power was going to gobble up the negative anyway, and you just skipped it, that's fine. 25, you couldn't drop the negative completely because the odd power would leave it negative. But if you'd rather throw a single negative to the front somewhere instead of leaving the negative in the parentheses, that would be a fair trade. But none of what I just said the last 60 seconds is necessary. It's just allowable. 26, keep on your run.
X squared over y cubed.
True.
2a squared over b to the fifth.
True.
2a, x squared over y squared.
True.
A squared c to the fourth over b to the third, d to the fifth.
True.
X squared y squared.
True. If you get tired, you can pass it off. You've been reading for a while, or keep rolling. Your call.
A squared y squared over x cubed b cubed.
True.
3 to negative 4.
True.
9 to negative second.
True.
Negative 16 with parentheses to the negative second.
That's true. We're about to start a run of 4 in a row that should all have parentheses in them.
Negative 8 with parentheses to the negative 6.
True.
5y with parentheses to the third.
Not to the third. So that's a nice run. Anybody slight adaptation on that one? It is negative third. Keep going, 37.
5x in parentheses to the negative fifth.
That's true.
3y to the negative fourth.
Not quite. It is a y to the negative fourth, but we need to do something a little different about the 3 on that one. Somebody have something where you did something a little different to that 3? Yeah.
Y to the negative 4 over 3.
Yeah, the 3 wasn't part of the power. The 3's just kind of there, minding his own or her own business. So you just leave the 3 down there on the bottom. So 3 just sits and watches the problem be done. It would be y to the negative fourth on top of 3. Similarly, 39. B to the negative third on top of 4. Then we start to just keep doing the same thing, but on 40 we want negative powers instead of wanting positive powers.
Y to the negative 2, and then on the bottom x to the negative 3.
That's true.
A to the negative 2, d to the negative 4, and on the bottom is x to the negative 3, and b to the negative 4.
True.
And then x negative cubed, y negative 5.
That's true. No fraction at all left on that one, although you could write it over 1, but don't need to.
And then 43 is x to the negative. Is it still half down?
Yeah. Still negatives everywhere.
X to the negative 3, and b to the negative 3, and then on the bottom is a negative cubed, squared, and then y negative 3.
That's true.
And then 44 is 16.
True.
45 is 71.
True.
46 is
Almost.
negative 11.
Negative 11, yep.
And then 47 is 544.
True. That's it, right?
Yeah.
Okay. Almost had them. Slides are quick.
Is that
I
the
don't-
bug killing book?
Yeah, that's the count. Lots of bees and one grasshopper have been killed with that book. I've never gotten a fly with it, I don't think, and I don't think this fly is going to be the first one because he's quick. The 47 repeats, questions, clarifications. We got about 5 minutes left. Anybody need something I can do to help you out with that? If you're done, make sure it's labeled as page 33 and send it down. If you're